Everyone, Hector Mendoza here. In this video, I want to explain the difference between DPI, PPI, LPI, and vector image. So DPI is dots per inch, PPI is pixels per inch, LPI is lines per inch. And we're also going to talk a little bit about vector images. So you're normally going to deal with this kind of images if you're dealing with Photoshop or Illustrator. There's a lot of other programs, but these are the most common ones that you're going to use this kind of data from. So I created a 4 images. One of them is a 30 DPI. One is 60 DPI. One of them is 100 DPI, and the last one is 300 DPI. As you can see, the 30 DPI is very rasterized. So each one of these images have a 1 inch by 1 inch circle that I created. Okay, and as you can see, the 30 DPI is very rasterized. When people talk about rasterization, this is what they're talking about. You see those pixels? Those are pixels. And the lower the DPI, the more pixelized an image looks. Okay? The 60 DPI looks less pixelated. The 100, as you can see around these corners, they're less. And then you get to your 300 DPI, they look like this, which almost looks like a vector image. As you see how smooth the 300 is? Look at the 100. It's starting to become more pixelized. The 60 is even more pixelized, and the 30 is very pixelized. So I'm going to get my machine to talk to us to explain it. Instead of me reading it and stumbling through words, I'm just going to have my machine read it to me, and then I'll come back and explain what all this means.
The terms dots per inch, DPI, and pixels per inch, PPI, are commonly used interchangeably to describe the resolution of an image. However, the terms do not mean the same thing, and there are distinct differences between the two. DPI refers to the number of printed dots contained within 1 inch of an image printed by a printer. PPI refers to the number of pixels contained within 1 inch of an image displayed on a computer monitor. Much of the confusion between these two terms happens for a couple of reasons. First, even though PPI refers to the resolution of an on-screen digital image, it can also affect the quality of the final printed picture. Second, even some professional print services request that pictures must be at a certain DPI level before they can be printed. What they normally mean is PPI, not DPI, thus, this adds to the confusion. The term DPI is a method to determine the print size of an image on paper. Although some printing applications still use DPI, many newer printing applications instead have a setting so you can select at exactly what size, 5 by 7, 11 by 17, or other, you want to print a photo. For printing applications that use DPI to determine the print size, increasing the DPI will make the size of the printed image smaller, while decreasing the DPI will make the size of the printed image larger. PPI represents the quality of a digital image displayed on screen. But it also contributes to the quality of an image. If a digital image contains too few pixels, the picture will not have very much detail and appear pixelated. Digital images with more pixels have better detail. The amount of PPI is determined by the image size of the photo. Notes: many digital cameras will have an image size setting in the camera menu. For the best picture quality, use the highest image size setting available on the camera when taking pictures. Refer to the operating instructions provided with your camera for information about possible image size settings. Raster graphics, JPG/PNG/TIFF files. Most people are familiar with .jpg images, like those you would get from your digital camera. If you have ever zoomed in very close, or blown up a .jpg image too large, you may have noticed that the image becomes blurry and the colors turn into small squares or dots. The small dots are called pixels, and this kind of image is called a raster graphic. If you have ever had to edit a digital photo, you know how time-consuming changing just the littlest thing can be. Vector graphic, AI/EPS/SVG files. Vector circle. So what is different about a vector image? You see hundreds of vector graphics a day, and probably don't realize it. Most logos are vector files. More specifically, a vector graphic is an artwork made up of points, lines, and curves that are based upon mathematical equations, rather than solid colored square pixels. This means no matter the size or how far zoomed in the image is, the lines, curves, and points remain smooth. The artwork will never have jagged lines or blurriness. Also, colors are separated into their own shape, versus a bunch of little squares making a colored area, which makes changing colors within these graphics as easy as the click of a button.
All right. So when we were talking about those vector, let's go to the last thing she was talking about, and that's vector. So I have an image here. Also, this image was built in a 3x3. Now, it's a vector, so there's not a DPI on this because it's vector. So as she was explaining, no matter how big I enlarge this circle, it will never rasterize. I could print this thing to, if you had a printer that would print 50 feet by 50 feet, at the end, it would look this smooth, depending upon the resolution of the printer itself. But if it was able to distinguish vector images and it had a 1200 DPI printer, then it would look as smooth as you see it here. Okay, so this is what we're talking about graphics. Vector, is something that you can skew, and this thing is, it's a vector. This is what they talk about vectors. Okay, now, so when we were talking about this, here, let me move this out of the way. So now when we were talking about rasterized images, let me show y'all a few images that better explain what we were talking about. Okay, so let me open up some images that I have here on my desktop. I have 3 images. One of them is an 8.5 by 11 at 600 DPI. So when you're talking about line per inch versus DPI, you increase it by 200%. So a 150 line screen would be 300 DPI. Now, if you can get things to print at if you can save the image at 600 DPI from its original image, then you're going to have a real nice image. This image here was created on an 8.5 by 11, and this one is 30 DPI. Now, this one here is the original image, and that image here, let me open up with Photoshop. Give me a second here. I want to open it up with Photoshop. Okay, here we go. This is Photoshop 2020. Okay, so I already have it open. Let me open it up. Okay, and it's on another screen. Okay, so here is this image that we're talking about. Now, this is the original image that came out of my camera. Actually, I think it came out of my iPhone. So this particular image is image size. Okay, so this image is 42 inches wide by 56 inches tall. It is at 72 DPI. Normally you wouldn't print at 72 DPI unless if you wanted to look rasterized like the images that I'm about to show you. But because it's so huge, 42 inches, when you reduce this, the programs repixelizes the image. They're called resampling. So, and that gets into a bunch of other stuff that we're not even going to talk about. But one thing you can do to this image is alter it if you have a program like Photoshop. Okay, so now let me show you a few things about this image. If I was to enlarge this area, huge, you see how right now I'm enlarging it 343%. So if I imported this into Word, InDesign, PageMaker, CorkExpress, any kind of graphic program, and I reduced it to 8.5 by 11, it would look real nice. And especially if I do this to it. If I would go in, get the same image, let me open this up, this image here. Okay, so now I'll just open up this other image. Okay, so now we got two images. The one on the left, it's a 72 DPI, and remember, it had a like 42 inch wide, right? Now this one here, I went and converted this one into an 8.5 by 11 at 600 DPI. So when I enlarge, you see how nice and smooth it looks, and that's at 228%. Okay, so now when you print this, this is what it would look like in the printer. Now, if you were to get this same image and let's say that you saved it as 30 DPI. This is what it would look like right here. So now this one is at 30 DPI. When I enlarge it, look what it looks like. See the pixelization? This is what it would look like if you were to print it. It would look pretty pixelized. So that is what that we were talking about when you're talking pixels, line per inch, and vector images. If you have a good computer, a good printer, for instance, my particular printer will print up to 600 DPI. It will also, now, if you do save something at 600 DPI, the image is going to be much, much higher. So when you're dealing with large images, you want to make sure that you have a lot of RAM. Your printer itself has a lot of RAM because now you're talking huge, huge images. And let me show you the difference between those, the sizes of those images. In a later video, I'm going to talk about also Photoshop images, JPEG images, TIFF images, and a few other kind of images that have, they will look the same, they will print the same at the same resolutions, but it could be a 3 meg file compared to a 95 meg file. So This particular image here, the one that is 30 DPI, if you go into your image information, this particular image, the whole image is only 254 kbytes, which is approximately 0.25 of a megabyte. Okay, now let's see what this image is. This image is the 600 DPI at 8.5 by 11. That one is going to have a much, much, much higher image. Image size. This one is 92.2 megabytes. Okay, now if we go to the original, if we go to the original one, that particular one is 34 megabytes. Okay, at 72 DPI. This one, this one here and this one here would print the same in reality. You wouldn't be able to tell the difference. Now, of course, this one is a bigger file, has more pixels. It would actually print better than this one, but most people wouldn't be able to see the difference. Well, I hope I explained this pretty good. Now, I am going to have a bunch of other videos that's going to talk about the different kinds of files, like JPEG, Photoshop, TIFF files, and other kinds of images. So stay tuned and I'll explain what all that stuff is. Thank you for watching this video. I hope you enjoyed it. If you like it, give me a thumbs up and I will see you in the next video.